For the next problem, we consider the population of planet Earth. It's currently about 7.8 billion people. If the world's population increases by 1.1% every year, how many years would it take before the world has 10 billion people? So first, let's try to write a function for the population of the Earth after x years, where x is the number of years from now. So 7.8 billion it's a lot of zeros. I believe that's right. Times 1 plus 1.1%, which in decimal is 0.011. So 1.011 to the power of x. Now let's take a minute and just understand where this formula came from. X is the number of years after right now. 7.8 billion is our current population of the Earth. And 1.011 represents the fact that the population is growing at 1.1%. So again, we take our formula for exponential growth. We have 1 plus or minus r, where r is the rate of change. And here our r is 1.1%, or 0.011. Another way to think about this is that every year, the world's population is 101.1% of what it was the year before. You have everyone that you have, and then you have some new people as well. Now, in reality, of course, you don't have every person that you had a year ago. Some people die, but more people are born and replace those. So the net effect is a growth of 1.1%. So the question is, how many years would it take before the world has 10 billion people? So essentially, we're trying to solve the equation f of x equals 10 billion. And we want to find x. In a future chapter, we'll learn how to do that mathematically. For now, we'll use a graph to find out. F of x equals 7.8 billion times 1.011 to the power of x. Now again, we're going to have to zoom way out in order to see this. Notice how these exponential functions get big very quickly. Okay, again, I'm going to want to draw a line at y equals 10 billion. Okay, so according to this, our purple line is our exponential growth function, modeling the population of the Earth. And this line is the line that marks 10 billion people in population. So these lines intersect at 22.7 years. What this tells us is that in 22.7 years from today, if current trends continue and the world's population increases by 1.1% every year, then the world's population will have grown from 7.8 billion to 10 billion human beings. So our answer would be approximately 22.7. Just make sure that's correct. Yes, 22.7 years. In other words, f of 22.7 roughly equals 10 billion. Lastly, okay, I'm trying to buy a used car so that I can discover what the rest of the world looks like beyond a 1 kilometer radius of school. True story. If I buy a car for $8,000 and it depreciates at a rate of 2% every 3 months, how much can I sell it for in 2 years? Okay, so now we're going to be talking about depreciation. So this is going to be exponential decay. So this is very similar to exponential growth, except we're going to have a base that, rather than being greater than 1, is between 0 and 1. So our function is going to have the same basic setup. F of x equals our initial amount, $8,000. And this time we're going to have 1 minus r to the power of x. And this is going to be $8,000 times 1 minus 2%. 1 minus 0.02 to the power of x. 8,000 times 0.98 to the power of x. Now the problem right now is that we need to actually figure out what to plug in for x. So this says that it depreciates at a rate of 2% every 3 months. The question asks, how much can I sell it for in 2 years? So we need to find out how many 3-month periods there are in 2 years. Well, that's fairly straightforward. 3 months goes into a year 4 times. So there are 4 3-month seasons in a year. So in 2 years, you will have had 8 3-month segments. So in other words, the car will depreciate 2% every 3 months, and it will do that 8 times over the course of 2 years. So our x should be 8. So we want to find out what is f of 8. f of 8 equals 8,000 times 0.98 to the power of 8. Now, we could also graph this. So we could plug in 8,000 times 0.98 to the power of x. Again, we're going to have to zoom back in to get a more reasonable scale on our graph. Now, as you can see, the shape of this is different from the previous examples. This represents exponential decay, so the graph gets smaller as time goes on. The car starts at around $8,000, and we want to find out what happens when x equals 8. So this represents a passage of 8 3-month periods, so 2 years after purchasing the car. You can see that the value of the car has gone down from 8,000 to 6,806. So we get f of 8 is approximately equal to $6,806. So hopefully I would try to sell it for at least this much money. Hopefully more, so that I can make a profit. For the last part, you're simply asked to rank these in order from biggest to smallest. Specifically what that means is, in terms of long-term behavior, which of these functions will eventually win? Which of these functions will eventually take over all the others? And then we need to rank them in order of size. So it doesn't really matter which one is the biggest at, which one has the biggest y-intercept, for example. That doesn't matter. What matters is the long-term behavior. So first of all, it's very important to notice that some of these represent decay and some of them represent growth. So this one represents decay because our base is a number less than 1. 99 over 100 is less than 1, so this represents decay. Likewise, h of x, our base is 1/2. So the number that is being raised to the exponent is what matters here. Each of these is less than 1. This represents decay. Only the middle one, g of x, represents exponential growth because it has a factor, a base that is larger than 1. So immediately we know that g of x is going to be the biggest, according to this metric. Now, comparing f of x and h of x, we can see that one of these gets smaller faster than the other. So h of x, every time step, every interval, the amount is shrinking by 50%. So it's losing 50% of its value with every step of x. On the contrary, f of x, the top function, is only losing 1% of its value after each time step. So it's always left with 99% of what it had at the previous time. So this will get smaller, slower than h of x. So the correct ordering would be that g of x is the biggest, then f of x, then h of x. Thanks for